Hello and welcome back to a new video. This video is going to be me explaining my version 2 of a Wordle game in C++. So I have all the code right here. I have the words.h header file. I have the definitions for the object-oriented programming, and then I have the main function in here. So I'm going to go ahead and recompile, test it first. So to start, you have options. You can print the rules, and it tells you what the rules of the game are, and then you can press S to start the game. So I have it to where it prints out the correct word just for video purposes so that I can test a little bit faster. I'm not very good at Wordle, so if I didn't have this here, we would be sitting here for hours for watching me guess the words. So let's just start with my normal word, which is stare usually. So it's going to tell you the letter pool, which it puts a period for the letters that are not in the word. And then it's going to give you guess data, which tells you if the letter is capital, that means that the word or the letter is in the right spot. And if and you can see that because the word is whose, so the E is at the end. And the S is lowercase because it's in the word, but it's in the wrong spot. So let's just say I want to guess thing. So the H is in the right spot, so it's going to show up as capital. And let's just say if we were to guess a word that's 6 letters, for example, blocks, I don't know, not in word lists. So also another thing about the curation of these words, there's no plural words in the list, and there's also no words with repeating letters. So if I just want to get the word right, it's whose, and then you have the option to restart the game. Just to show you guys the list of words in my Finder. So there's 1,035 words, I believe. I just curated this from a website of like the most common 5-letter words. And yeah, so that's pretty much it for the testing purposes of it. I believe it works. So I want to get into the explanation kind of it. So I'm going to go ahead and just press Q to quit. Exit out of there. So starting off with words.h. So for this version of my Wordle game, I decided to use object orientation. Previously, my first version of this in December, I believe, I didn't have object orientation because that was pre 3330. So I hadn't taken that class yet, so I didn't know how to do object orientation. So I just stored all the words into a struct. But now I have a class called word. It has a string object that is a word, and it also has a default constructor, just a conversion constructor, and then a getter for getting this actual string so that we can print it out, because if we ask the compiler to print out a word, it's not going to know how to do that because it's an object created by us. So then we have the word collection. It has size and capacity of the word collection. I decided to make this dynamic because, for example, if I want to add words to the word list, then I wouldn't have to hard code it. So one thing that was a little bit of a flaw in my previous version is that I would have to go back into the code and hard code the list, including how many words there were in the text file. So now, since it's dynamic, it's gonna basically go through and add each one and reallocate memory if needed. That'll be more in the words.cpp. So it also has a list of words. It has a correct word, user guess, letter pool, and guess data. And then I have my default constructor, destructor, since we're handling dynamic memory. We have a assignment operator overload, and then we have a copy constructor add word getters and setters, and that's pretty much it for the declarations of these things. Now for the definitions, the default constructor is pretty easy. It's just every time a new word is called, it just makes an empty word. And then the conversion constructor makes this string into whatever we passed in here, and then we have a getter for getting the string of the word. So for word collection, we have a default constructor. We set size equal to 0 upon initialization. We have capacity equal to 500. I could make this 1,000, but it doesn't really matter. I made words equal to a new word, and then I put capacity in there. So we're starting off with 500 words as a cap, and then each time we add, it'll be more down there. I'll explain further. Letter pool. This is a pool. It is a string object because C style strings are very annoying to deal with. I've had my fair share of seg faults using C strings, so I decided to just use a string object since it's also like I can iterate through. And then I have my guest data, which actually I don't need anymore because, yeah, I don't need that anymore. I'll explain why. But so I have my destructor, which just deletes the dynamic words list for garbage collection at the end of the program. Getters, which just return private variables. This actually returns a pointer since words is a list. And then I have my assignment operator overload, which basically just it just makes a new object. It copies everything over from this variable into a new object, and then we delete words and then reallocate this one. We reallocate for this object. And then we just return this, which is a pointer to this object that we're currently scoped to. And then we have the copy constructor, which makes a new word, and it also so it makes a new word, and it does it according to a different object that we already have. So we have copying over similar to this. And then we set words equal. Oh, I was trying to remember what assignment operator overloads do because I haven't taken 30 through 30 in a while. But basically, it makes the object that we're currently scoped to identical to the one that we pass in. So since it already has its own words list, that's why we delete it. But this one, since it's brand new, we can just allocate new word. And then it just passes in everything from the right side into the left side. So yeah, that's it for that. And then so we have add word. So it's going to take in a word and it's going to add it. So if size is greater than or equal to capacity, then we're going to make a new location that is 500 more spaces than the word list that we currently have. And then we're going to pass in everything from our old list into our new list. And then we set our capacity plus equal 500 because we just did that here. And then we set the next iteration, or I'm trying to think of the word. This is basically just adding the word to the list. And then we have some setters, which gives us the ability to change these values of user guess and correct word. And then getters, pretty self-explanatory. And then set letter pool. This changes the letter pool, which we have initialized up here. So this changes it so that we can print out the letters that they still have left, the user, because it puts a period for the letters that you've guessed that weren't in the list at all. And so yeah, it's basically just changing it. So if we go to our main function, I have a check guess, play game, print rules, print menu. So yeah, it gives you a greeting. Okay, so this is very important. So this is basically um, making sure that we get a different random number each time for each compilation. So it's based off of the time, which changes every second. So it bases the seed of the random number generator based off of the current time. So it's just to make sure that we get a different number each compilation because random numbers in C++ are kind of iffy. So then it's going to print the menu, which it gives you the options, and then it's going to give you a choice. And then it basically goes through, as long as you don't press Q, which is quit, then it's going to keep running. Play game is if we press start, and then after, if we do R, it's going to do print rules, and then it's just after you play the game or after you print the rules, it's going to give you another option, so that you don't get stuck in this loop, in this while loop, because the value would never change. So print rules, pretty self-explanatory, just prints the rules. So play game, I create a new place in the heap for a word collection. And then I initialize some variables. So I have stream in. So this comes from fstream. This allows us to manipulate files and open files. So the variable name for my ifstream is just myin. So myin.openWordleWords.txt. So this is important. If you're compiling on a Windows machine, then this is going to run normally in your command prompt. However, if you're on a MacBook, it's a little bit more difficult. You're going to have to change this to your absolute path. This compiles on my IDE, but if I were to compile this on my machine, it's not going to know what this is because it needs the absolute path, which if you don't know, this would be like /users/your name/ downloads or whatever it is. Basically, it needs to know the exact path name. And I'm going to try to upload this, make this accessible on Replit, so that the normal user doesn't have to update the code to their path name, because then it would be a lot less accessible. So I'm going to try to figure out how to do that. But if you want to just go ahead and change this to your path name, you can, I believe. So if I go to terminal, if you just do pwd, print working directory, actually, so change directory, I probably shouldn't do this on a video, but basically you would go, I don't know, it's hard to explain. I'll have a README folder. I'll have a README file on the GitHub repo, so I'll explain that in the GitHub repo for the next steps. So if it doesn't open the file correctly, it's going to tell you that there was an error. If not, it's going to go until it goes to the end of the file. And it's going to, so each word is obviously one word and then a new line character. So this is basically just getting the current word on the line, and then it's putting it into, it's using myin, and then it's putting that word that we're on into a string, and then we make a new word based off of the string, which is calling the conversion constructor, and then we're adding that word to our new word. And is this a list? Oh, this is adding the word. Yeah. This is taking the what's it called? The dereference of the new word, and just putting it into words, which, if you know, this is our collection of words. And then it's going to delete new word each time because we called the new operator, so we need to have a delete. And then it increments word count. Then after it's gone through the entire file, it's going to close it, and then so this is the part I can take out because this is just printing out, or actually no, this is printing out the correct word. So I'm going to just take that out, resave it so that the user doesn't know the correct word and it can actually be a game. So this is just setting the correct word based off of random percent word count, which goes from 0 to up until word count, and I believe it's not exclusive so that we don't get a seg fault. And yeah, so it goes through a while loop while your guesses is not equal to, or so basically if your guesses is greater than 6, it ends the game, and if you guess it true, then it's going to end the game. So user enters a guess into a string, and then it converts that to a word, and then it sets the user guess to based off of what you just put in, and it puts it into this words because user guess is is a data type, or not a data type, but it's in the actual word collection class. And this is going through a for loop to make sure that the word that the user guessed is actually inside of the file. And then if so, it's going to go to the check guess function, print out how many guesses you've done, and it's going to increment guesses. If not, it's going to say it's not in the word list. So if we go over to this check guess function, it's going to, so that's why I got rid of it, guess data, which was still in, it was still in, it was still in the default constructor, but I didn't need it anymore because I wanted to put guest data inside of the class, but since it would need to be changed each time, each iteration, I decided it's best to just put it into the function, because we want to update the guest data after each guess, not after each program, if that makes sense. So this is just handling the guess based off of the characters. You know, if they get the letter in the correct spot, then it's going to uppercase. If they have it in the word but in the wrong spot, then it's going to put it, make sure it's lowercase. If not, then it's going to say that it's a wrong letter, and then and then it makes sure, or it changes the letter to a period if it's not in the list at all. And then if right letter, if they get it right, it's gonna change this guess bool to true, which is going to force us out of this while loop and in the game. And then it tells you got the correct word, and then this is just printing out the letter pool and the corresponding guess data. And that's pretty much it for this program. I've made a lot of improvements from version 1, and I think this is definitely a stronger program. Still combating that issue with Mac OS compilation, or running the executable, because you need the absolute path name right here. Which, if you notice, I did compile it in my IDE, or this would not have worked. So I'm going to put it in the README in the GitHub repo. So I'll make sure that it's at least outlined how to do it. So thank you guys for listening, and I hope this was a good video. Thank you.